and a full table scan. So mostly in the production environment, we don't recommend full table scan, because if the table is going to be huge, like 2 TB of data, for example, and it's going to do a full table scan, in that case it will hamper the system, like it will run for hours, uh, wasting the resource, right? So mostly we need to monitor, like if any full table scan queries are running. So let's first start with the primary index. So okay, so whenever we create a table with primary index, right? So when you run a query having a where clause, and you are using this primary index in that query, uh, then it will be a 1 AMP operation. Okay, so it will be fastest one, because only 1 AMP is getting worked on the query, and the result will be quicker. So coming to the second index, we'll see the examples of primary index too. So this is just a overview. So coming to the secondary index, this is the next fastest when compared to primary index. It's a added index which we are creating. Suppose we have a query which is not utilizing the primary index of the table. So in that case, what we can do, we can create a secondary index which is used in the where clause. So in that case, what will happen? The system will scan according to the secondary index, and it will fetch the data. So this will also avoid the full table scan in case if you are not having the secondary index, right? And we are not using the primary index in the where clause. In that case, what will happen? The system will scan each and every row from all the amps. So that is called as a full table scan. But due to this parallelism, like even if you have 1,000 rows and 100 amps, right? So each will be having 10 rows. So even full table scan is fastest, but when the data is huge and table is bigger, so we don't recommend full table scan. So we have to find out a way to avoid the full table scan.
Okay. My question is, if the query contains if the queries does not have any primary index and secondary index, then it will go for full table scan only.
In the where condition you're asking, right?
Yeah, say in the where condition,
right.
We are not mentioning primary index and secondary index. Both indexes are not used.
Okay.
So in that case, that query will go for full table scan only, correct?
Yeah, in that case, it will go for a full table scan, unless if we have the stats collected, right, on any of the join conditions or where clause. So this is an exception. Like if you have the stats collected on it, then the explained plan will change. So it won't go. Still, it will go for a full table scan, but the performance will be faster.
Oh, okay. Okay.
So the primary index basically performs three activities. First one is data distribution, and second one is fastest way to retrieve the data. And third one is when we are using joins, right? And when you use the joins in the condition, it's really helpful for getting the data in a fastest manner. So we have actually two types of primary index. First one is unique primary index, second one is non-unique, and in that it separates like unique primary index, non-unique primary index, unique secondary index, non-unique secondary index, and we have partition primary index, right, where the data is getting partitioned. So we will see that in with an example. And the latest one is no primary index. So recently they introduced this NUPI, where we can create a table with without a primary index. So what will happen at this stage is there won't be any hashing done on the primary index. So data will be evenly distributed on the AMPs randomly. Right? So it's not, no, most of them don't use that in production because it can be useful in a staging activity where you load a
it won't go for hashing algorithm, you mean to say?
correct. This NOPI won't be the rest of the UPIs, right? Rest of the PAs, right? They will go for the hashing except non-unique secondary index. Okay. So, but this NOPA, right? So it won't go for hashing. Like system will take the total number of rows and it will evenly distribute among the AMPs.
Okay, but how it will do the tracking in case of NOPA? What exactly it will
Yeah,
takes it in?
we'll see how it is getting.
Okay, fine. Yeah. Okay, yeah.
Okay. So let's start with unique primary index. So whenever unique primary index is defined on the table, right? So if you enter unique value, right? If you, for this example, we have the UPA and the employee number. Okay, if you see the first column, it's employee number, it's and it's unique, right? So whenever we hash the value, right? So this is an example shown in a single AMP, like AMP4 we have taken as an example. And whenever we insert the values, like different values, and it gets inserted into the AMP, before the row, right, there will be a uniqueness value will be added. So if you see here, everything is one, which means there is no duplicate. So unique primary index doesn't allow any duplicates to be inserted when defined. So in case if you have a record with a duplicate value, for example, if you insert a value with 99 again, that record will be rejected. Right?
Okay.
And this row hash we saw earlier, 32-bit plus this uniqueness value, it's called as the row ID. This combination is called as the row ID.
Okay.
Right? So, and this one is for non-unique primary index. So if we see here, this is again for AMP4, but you see the uniqueness value here changes according to the rows. So here the non-unique primary index is defined on the last name of the user. Sorry, last name of the user. So if you see here, there are 3 Davis and 1 Allen. So when we see for Allen, there is only 1 and uniqueness value is given as 1. But for Davis, it has been incremented, like starting it's given as 1 and then 2 and then it's incremented to 3.
Oh.
Okay. So again, this unique primary index, right? The data will be distributed evenly among all the AMPs, right? Because it's unique and it will be the table data will be evenly distributed. There won't be any skewness, right? And in the case of NUPI, it won't be uniquely distributed. Some AMPs will have more number of records. Like if you see here, this AMP4 is containing almost 3 rows of this Davis, right? So
Yes.
only partial AMPs will be having the records depending on the row hash value.
Okay.
Okay. And so this is a pictorial representation of how this non-unique and unique primary index. So if we see the example 1, right, the one we saw.
Okay. Yes. Okay. Yes. Yeah. Here distribution, first 2 cases distribution is not proper. That
Right.
will create a skewness and amps are not utilized properly.
Correct. Yeah. So if you see this one, first one is non-unique primary index, right, with last name. So when it comes with Davis, it's stored in one particular amp, and with Smith, which is duplicated, it's stored in another amp. So remaining unique values, it's stored in other amps accordingly. So if you see here, this first amp and this third amp, it's queued actually, right? It's containing more rows when compared to others, correct? So if you do a select star from this table where last name is Davis, so what will happen? Only this amp will be working, correct? Because the other
Correct, correct.
amps doesn't have the record. And
Okay.
yeah, and the second example is same with the gender. So if you see here, the male will always go into one amp and female will always go into one amp. So when we do a select, so only these two amps will be working.
Okay.
And this is the another example for the unique primary where the data are evenly distributed.
Okay. Okay.
Okay. So this we saw yesterday, just a refresh, like how the select star from a table will work, right? It will go to the PE, and this where condition which we specify will be hashed, and it will see for the particular amp where it is stored from the hash map, and from there it will retrieve the data.
Okay.
Okay.
P here is parsing engine, correct?
Yeah, parsing engine, right?
Okay. Parsing engine will generate the hash value, correct?
Correct. Yeah.
Okay.
So everything is done in P. Only the data retrieval and data writing is done from the amps. So remaining all the things will be done by the P.
Okay. Data retrieval and data.
Writing of data to the disk.
Okay. 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 Amps. Okay.
Yeah. So if we see here, there's unique and non-unique primary index, right? It's always one amp operation. So if we consider for UPI, so we have the unique value stored. So either if we do a select, right? So one particular amp will either give 0 records or 1 record, right? So if you see here, if you do a select here for 1, it will, if the amp contains the data, it is 1 row, and if if it doesn't have any, then it's 0, right? So
Okay. Okay. Yeah.
only one amp will be working. And even in the case of NUPI, it's a single amp operation, right? So if we consider here,
Because all the same row
yeah,
hash values will be set in the
same
same amp.
amp, correct? Yeah. So when we do select on Davis, so only this amp will be working. So when we say,
Okay. If it is cannot be accommodated in one amp,
hmm,
does it take it into a second amp? No, that many values are how exactly in anything such scenario?
no, this is all, no, actually, this is not getting stored in the AMP. This is a pictorial representation, right? Anyway, it's getting
Okay.
stored in the this. So, but it will have the AMP number, like in the hash map, right? It will have the AMP number. So through that AMP only, it will be going.
Okay, okay, okay. Now my question is,
Hmm,
say you have so many values.
correct.
Is there any scenario? No, I'm just assuming. Okay,
Okay.
okay. Uh, so many values are there.
Hmm,
Okay, that cannot accommodate in one amp.
okay.
Okay, so in
Okay.
the sense like same value, same value.
Correct. So okay, so in this case, right, like if we have more number of values in one particular amp, so what will happen, that that amp will be skewed and it will be called as hat amp, and there is chances of that amp is going out of space actually. This happens in real time environment. So what will happen, though if consider database which is having of 100 GB of data,
Okay,
right?
say you said here is second example, no, example to male and female.
Correct.
Okay, there is a country population data.
Mhm.
Okay, yeah, obviously when you created a primary index on these two,
Mhm.
okay, it has to fall under the same amp
Correct.
only. Okay,
Correct.
but
Yeah.
so many values will be there in this case.
Mhm.
Will it take amp 1 and 2 if the values are more for male and female amp 3 and 4, like
No,
that?
no. It will always go into only one particular app. So what will happen if you consider a database having 100 GB of data, right? And
Okay,
you have around 5 amps. So what will happen? 20 GB will be divided and given to all amps, like 5 amps. So might be in this example, if we have 40 GB of data, so each amp will be given 10 GB of data. So what will happen when this particular amp one, when it reaches 40 10 GB of its size, right? So
yeah.
the next row which you are inserting, it won't be allowing, saying that there is no more room in
Room in database.
the database. Yeah.
Okay.
So in that case, we need to check like which table is queued and what is the PA, whether it's not properly given.
Okay. Yeah. Okay. Yeah, I got it.
Okay. Yeah. So unique primary index and non-unique primary index are always be one AMP operation. So coming to the secondary index, so secondary index is added index apart from primary index as we discussed. So it can give the no improvement in performance when it is utilized. Like in case if we are not using the primary index in the wait class, and if we see that some other columns are getting used, then we can create a index on those columns, so it will be used. But one a disadvantage of second index, right? So a subtable will be created uh, whenever we create a secondary index, and that subtable will also consume some space in the database. So though it won't be visible for users or even DBAs, like we won't be able to see the data. It will be internally used by the system.
Okay. It will also stored under perm space, right?
Yeah, it will also store under POM space.
Okay.
It's actually a added weight for the system. Like it has to maintain
Okay.
the
Yeah.
subtable too.
Okay. And that table, that subtable contains row ID and primary index information. I think
Correct,
so. Correct.
correct. Yes, yeah. Though we won't be able to query it, it contains the row ID and um, this row hash value.
Okay.
So okay. So another disadvantage of the subtable, right? So whenever you do a insert, suppose if you run a fast load on a table, right? So if it is having a secondary index, then in that case it will throw error where you need to drop the index and then you need to load it again. And also
Okay.
whenever you insert a new row, in case of multi-set, in case of multi-load, if you
Mhm.
update, if you insert a row or something, right, this subtable has to be updated. So the processing will be increased in case of having this second index. So we need to consider all these scenarios while creating the
Okay.
second index.
Okay. Okay.
So these are some of the rules for the subtable, like secondary index. So secondary index is always optional. So it values can be unique or non-unique. Likewise, unique primary and non-unique primary index. This also can be unique or non-unique. And the values in this secondary index can be null, whereas in primary index it can't be null. And second index values can be modified. In that case, in the case, like, we can modify the index, right? So you can drop and recreate with a new index, but that is not the case with the primary index. So primary index once created, it should be.
If primary index has a null value, then it won't accept your saying, right?
Yes.
But we may have nulls, no? That is allowed, right?
No, so if you see in the case of unique primary index, right, where
Uh-huh.
always the data should be unique. So in that case, if you insert a null value, it won't accept.
Correct, correct. Yeah. Yeah, yeah. In case of non-unique, it will accept.
Yeah, in case of non-unique, it's okay. Yeah.
Okay, okay. If they want to enforce primary key kind of a concept, means they should go with the UPI, correct?
Uh, can you come again? What is that?
No, there is in a relational database,
Mm-hmm.
there is something called primary key, foreign key.
Correct. Yeah.
Okay. So that's the referential integrity. So if
Correct.
we want to enforce that uniqueness using the primary key in the primary key column,
Mm-hmm.
in that case we should use UPI, correct?
Yeah, yeah. In that case, we can go for UPA.
Because NUPI won't give that because it will allow
Duplicate.
duplicates also.
Correct. Correct. Yeah.
Okay, okay.
So another limitation for this secondary index is we can have around 64 columns. So when we take the primary index, right, we can have around 16 columns in a combination. But in
Okay, okay.
second index, we can have around 64 columns.
Okay, okay.
So as we said, there are two type of second index, unique and non-unique. So we'll see one by one on that. So the first one is this unique secondary index. So this again enforces the uniqueness in the column or group of columns which we specify. So again, it speeds up the data access, data retrieval. As I said earlier, whenever we create a secondary index, right? So then Teradata will immediately build a secondary index subtable on each AMP. So each AMP will hold the data whenever data is getting inserted into this table. So
Okay.
yeah, so each AMP will then hash the secondary index value for each of the rows in the base, as I said earlier. So this will contain the hash value plus the pointer value in the subtable.
Okay, that means whenever you are using a secondary index value in the where class,
Mhm.
first it will do a hashing on that value, correct?
Correct, correct, correct. Yes. If
So
yeah,
yeah, yeah, by the while seeing that, it will get to know that this is a secondary index, and it should go for the subtable first, right?
correct. It will go for the subtable and then it will retrieve from the AMP wherever it resides.
Oh, okay, okay. Sure.
So this is the syntax for creating unique secondary index. So create unique index and the column or combination of columns and DB name and table name. Okay. So this we create after creating the table, right? We create it independently after creating the table.
Sorry, after creating?
Like first we create the table with primary index and then we add the secondary index like independently. It's
Oh,
not
okay,
like
okay.
we do with the same DDL with the creation, right?
Oh, okay, okay,
Can
okay.
run
Yeah,
both.
yeah, yeah.
Yeah.
It's not like we need to create during the uh, create during running the definition itself.
Correct. Yeah, right. That's what I mean. Yeah.
Okay, okay. Yeah.
And this non-unique second index, as you know, it allows the duplicates for the different columns. And this non-unique, right? So it basically it helps to prevent the full table scan where every row of the table is read. So usually when we create this non-unique secondary index, right, where the full table scan queries are running, we can identify the columns, and if there is duplicates, if we create the non-unique secondary index, then mostly this full table scans are avoided. So even in this
Okay,
case,
it will be 2 amp. Okay, okay. Yeah.
yeah. Uh, what was your query?
No, no. You okay? This is saying no. Okay, it's a 2 amp operation.
Yeah. So here, unique secondary index is a 2 amp operation, but the non-unique secondary index is a all-amp operation. Okay, so all the amps will be working when you have a non-unique secondary index, because again it's a duplicated value, right? So it will be in any of the amps, correct? So in case of unique secondary index, so one amp will have the value and the other amp will hash the value, correct? So it's a 2 amp operation, and in case of
Correct, correct.
non-unique, it's a all amp operation.
Okay, okay. Yeah, yeah, yeah. Okay. Okay, but okay. Can you go to the this slide? And
Yeah,
you're saying it is prevent full table scans in every row of the table is read. Okay, it won't go for a full table scan, um, but it will go for all amps, right? If
yeah,
required means.
yes, it will go for all amps. Yeah.
Okay, okay. Okay, fine. Yeah, you can go to the next slide.
Yeah. So the next part, the next index we have is partition index. So why we use this partition index is to avoid the full table scan again. So suppose if we have 10 TB of data, and then we are doing a select on that table. So all the 10 TB of data has to be stored in your spool, and then in whatever condition you give, right, that has to be filtered out. So what will happen sometimes, the spool will run out of space, so you specify a user with specific spool of 5 TB or something. Then in that case, if you run the query for 10 TB, then the user won't be able to retrieve the data. So you will get an error called no more spool space in the user. So to avoid all these things, right? So they came up with the partition primary index. So what will happen here? Every uh, partition will be stored like a individual draw a kind of thing, right? To imagine. So whenever you select from,
Sorry, Ashwin.
yeah,
Just to can you just repeat this? Why they came partition parameters? Can you please explain? You are saying some
yeah,
cool scenario. Yeah.
okay. So consider we have a table with 10 terabytes of data, right?
Okay.
So you are doing a select star from the table. So what will happen is all the rows has to be read from the table, and it has to be stored in the memory locally, right?
Okay. Okay.
And
Correct.
then
Correct. Yeah.
it will fetch you the result. Like in case if you have some filter condition or something, you do a join or something, then it has to be joined with another table, right? And then it will process the data and it will give you. So
Correct. Correct.
so when the data is huge, there may be a chance of the query failing due to spool space. So what is spool space is? It's like a temporary space given to the user to manipulate this data. Okay, so each and every user will have a limit of spool space. So example, if business users, they have 3 TB of spool, and ETL accounts will have around 10 TB of spool. So they can perform the operation within whatever they have limited.
Okay. Okay.
Okay. So if not the PPA, right? So what will happen? You have to query all the data, and then you have to join with other tables. So the memory will again run out of space, right? So this happens when in the production, right? When there is a bad query running, or when there is a product join happening. So there may be a chance of spool space is getting utilized 100%, and the query will fail. So the error will be no more spool space in the user account.
Okay. Okay. Uh-huh.
Okay.
No, that will affect only to that user, right? Not
Yes,
to
yes.
other users.
Only to that user. Only to that user.
Okay. Okay.
Yeah.
Yeah. Yeah.
So this partition will mainly be effective for no big tables, having huge number of records.
Okay. Okay. Yeah. Yeah.
We'll see about that. So there are basically two types of partition. One is case underscore n, and the other one is range n. Okay.
Okay.
So in this example, if you see here, so there is the unpartitioned PI, where if you see here, uh, if you see the order date, right? So it's all no, not arranged properly. So when you do a select star, all these records will be retrieved, correct, from each AMP. But in the case of partition, right? So each range will be stored separately. So if you see here, so this is for the month one, like it's for the January. It's stored separately as separate partition, and for the month February, it's stored separately. Means this table is partitioned by order date.
Okay. Okay.
Okay,
Yeah. Yeah.
so that's why it got partitioned with this date. So when you do a select, right? When you do a select and you specify the order date between or equal to or between anything for the Jan month. So what will happen here is only this first partition will be retrieved. The remaining all the partitions won't be read. Only the first partition will be read and it will be delivered. So in case if you are doing a complex join or something, so in that case this will be really helpful, where spool space will be less utilized. Also the computing power.